Hello everyone and welcome back to the AIEX platform. In previous videos we have covered creating a dataset, adding images, and annotating them for your computer vision project. In this video we will take the next step, which is creating a training version of your dataset and training a model using it. Before we start training the model, we have to create a training version of our dataset. A training version prepares our images for the training algorithm and also allows us to have different training versions of one dataset to experiment with various options without changing the original dataset. To begin, click on the Build New Version button. In the first step, you can see a summary of your dataset, including its total size, average size for each image, total number of labels or annotations you created on all images, average number of labels for each image, and the total number of images included for training. You should also choose a name for the version you're creating here. In the next step, you will see tiling options. Some training algorithms only accept certain image sizes. Larger images are downsized to fit this size limit, which might result in a loss of detail. Tiling images will break them down into smaller parts that fit the training algorithm's size limit and preserves their detail. You can choose the tiling method and the maximum image size. The next step provides augmentation options. This tool allows us to increase our dataset size by creating different variations of our original images. For example, we can choose to include an upside-down version from 60% of all images and a version with increased contrast from 50% of all images. In the next step, you can specify the percentage of images used for training, validation, and testing. You can choose not to allocate any images for testing, but most of the images have to be allocated to training, and there must be a percentage allocated to validation. You can also include images with no annotations as false positives to increase model generalization. The last step shows you a summary of the optimizations you have chosen. Click on Build to create the training version. Dataset training versions are accessible in the Train tab. Choose a version to start configuring it for training. Click on Dataset Health Check to have an overview of annotations in our dataset. You can see the distribution of annotations in the images in a heat map, annotation sizes relative to image size, and the distribution of annotation sizes. Image Metrics tab gives you a detailed overview of the distribution of annotations based on their size relative to their image. You can also download this training version from here. Click on Export Project and you'll be presented with a download link. After making sure there are no anomalies in the dataset, we can move on to the next training step. Here we can choose training algorithms from TensorFlow, PyTorch, Tau, and TF-Lite frameworks to train this dataset version. Different algorithms are used for different project types. The AIEX platform also lets you generate bounding boxes from segmentation annotations at this stage so that you can use object detection algorithms and train an object detection model from your segmentation dataset. The important features of each algorithm are highlighted here using these badges, which can help you choose the most suitable algorithm for your use case. Let's go with YOLO v5 from the PyTorch framework. You can choose your training parameters, and if you're an advanced user, you can also choose your training hyperparameters, which are different for each algorithm. Then click on Train to start training a model with this dataset version and based on your configurations. After the training is complete, you can find your model down here. Click to expand it to see more training details and metrics. You can see how the model did on validation and test images here, and compare its performance with the ground truth. You can also access the TensorBoard, which is an indispensable tool for debugging and experimentation with powerful visualization and analysis capabilities. TensorBoard lets you easily experiment with different machine learning models and track key metrics such as loss and accuracy through intuitive graphs. This tool is especially useful for visualizing training and validation performance over time, examining model architecture, and analyzing weight and bias distributions. TensorBoard also allows you to track custom scalar values, images, histograms, and embeddings. Various metrics for the evaluation and test portions of the dataset version are shown here. The Details button will show you a summary of the training configurations and parameters, and this button displays the training logs. If you decide that you no longer need this model, you can archive it by clicking this button. This menu provides options for accessing the TensorBoard, deploying the model, deploying it using legacy settings, downloading test or validation images, or downloading the model itself. Thanks for watching, and we hope you found this video informative. If you have any questions or feedback, feel free to leave a comment below or contact our experts. Don't forget to subscribe to our channel for more videos on AI and machine learning.